Hey everyone, and welcome to an episode of Mrs. Ross Does Math. Today's lesson is for Math 8, and it is Lesson 19, our topic, Distance on the Coordinate Plane. In this lesson, we will be taking our Pythagorean Theorem and applying it to a graph. So before we get into things, we're going to do a little bit of review today. So, like I said earlier, our topic today is Lesson 19. This is distance on a coordinate plane. First, our essential question is, how can I find the distance between 2 points on a coordinate plane using the Pythagorean Theorem? Now, I want to refresh your memory as we haven't done some graphing in a bit. And to first begin with, the first thing that I want to review is a coordinate plane. So simply, a coordinate plane is a graph. On our graph, we have 2 lines, one horizontal, one vertical. Our horizontal line is our x line. Our vertical line is our y line. When we graph, we have an ordered pair, and that ordered pair is x, y. So we're always going to want to make sure that when we graph something, we find it on the x first, meaning we're going to go left or right first, and then we'll go up, down. And again, the coordinates or ordered pairs on a graph are in the format x, y. Now, for this, we can create triangles using 2 ordered pairs and then find their distance diagonally by using the Pythagorean Theorem. So, we're going to go ahead and do a little bit of extra review before we get things going. So, here we are. So, to begin with, when we want to find the distance on a coordinate plane, we have a couple of steps that we should take. And that first step is to graph the 2 ordered pairs and connect the points together. The diagonal, we're going to label as a line, and we're going to label it as C. Because remember, in Pythagorean Theorem, we have a squared plus b squared equals c squared. We are going to be finding C, or the diagonal, in this triangle on our graph. Next, using C as the hypotenuse of a right triangle, we're going to draw the legs. Meaning, for me, it's easiest for me to draw dotted lines as I'm going through this. So when I go through and I graph my points, and I'm connecting them, and I'm creating the leg of my triangle, I'm going to go ahead and use dotted lines. You can use a solid line if you would prefer, though. Next, we're going to find the lengths of the legs. So we're going to use the lines on our graph to help us count, going from one point to the other. Next, we're going to use Pythagorean Theorem to solve for C. So we're going to plug in our values into our formula, and that's it. Now, I have an example for you that I've already worked out, and then we're going to do a second example together. Now, in this first example, it says, find the distance between 2, -5 and -2, 1. Round to the nearest tenth. For this first 2, that's an x. The -5, that's a y. So, when I have these here, I'm going to find this as 2, -5. So I'm going to go over 2. Whoop, need to move this up. I'm going to go over 2 on my x-axis, and I went down to -5 on my y. And I happen to put a point there, and that's this point right here. Now the next point was -2, 1. So I'm going to go over -2 on my x-axis, up 1 on my y-axis. Now, like I said, I'm going to draw a line connecting them together on the diagonal, and then I'm going to draw lines creating a triangle. Now, when I went from my 1 to the -5, that's 6 points, so I put a 6 right there. And when I went from the -2 to the +2, that was 4 points. So I wrote 6 and 4. Now, over here, I ended up using them once again in my formula. So we don't know what C is. That's what we need to find. My A, it's the first number I see. A is the first letter of the alphabet, so that I put as 6. B, I put as 4. Now, when I plug these into my formula, I get A squared plus B squared equals C squared. So I went 6 squared plus 4 squared equals C squared. 6 squared is 36. 4 squared is 16. When I add those two together, I happen to get 52. And then I square rooted them. Now, here in our directions, it says round to the nearest tenth. So I wrote down the 2 digits behind the decimal. That was 7.21, or in this case, the 21 is what we want to look at. The 1 next to the 2 is going to tell me if this 2 is going to stay the same or if it's going to round up. And in this case, it stays the same. So our answer is going to be 7.2 equals C. Now, the next example that I have for you is not one that I've done previously, so we're going to go ahead and do this one together. Here we go. So, example 2. It says, find the distance between 2, 6 and 5, 1. Round to the nearest tenth when needed. So, first I'm going to begin by graphing my 2, 6. So that's a 2 on my x and a 6 on my y. So I'm going to plug that right up here. Next, I have 5 and 1. So I'm going to go to 5 on my x, 1 on my y. Now I'm going to draw a line connecting those 2 points, and I'm going to label this as C. Now I'm going to draw more lines, creating a triangle. Next, I'm going to count how many times I go down. So I go down once, twice, 3, 4, 5 times. So I'm going to put a 5 on the side. And over here, I go 1, 2, 3. So I'm going to put a 3 down below. Now, we're going to plug this into our formula. We know that our formula is a squared plus b squared equals c squared. So I'm going to plug in the 5 for the a and the 3 for the b, and that's going to give me c squared. Now 5 squared is 25, 3 squared is 9, and I'm going to get c squared. 25 plus 9 is 34. So 34 equals c squared. Now I need to get rid of that squared, so I'm going to square root both numbers. And when I do that, I'm going to get 5.83 plus some additional digits on the end, but I really only need to worry about the 83, and that's going to equal c. Now our instructions, though, said to round to the nearest tenth. So I'm going to take a look at the number 8. Is the number 8 going to round up, or is it going to stay the same? If you said same, you are correct. Our final answer is going to be 5.8 equals C. Now once again, that number stays the same because this 3 right next to it isn't going to cause it to round up. This 3 is not 5 or above. Anything 4 or below causes the first digit to stay the same. If it's 5 or above, this 8 would change to a 9. Now that happens to be our answer. Now looking at our assignment today, you're going to be doing problems that are very, very similar to this. And I want to let you know that number 8 on our assignment is going to be extra credit. So if you want to give that one a shot as some extra credit, that is totally up to you. Now I'm going to get you going with number 1 and number 5 today. So please make sure that you put your name, the date, and the class period on both pages of this assignment. If you are not ready to start this, please pause this video. Please re-watch it. Go back through, take a look at the notes. I'll also attach some additional videos to this post So if you need additional help besides mine, you'll have some extra resources at your availability. So here we go. Name, date, class period, please. I'm going to put that on here for me as well. Today is 4/27/2020 for me. All right, so starting out. For number 1, it says find the length of C on the graph. Now this has already been graphed for you, so you get to skip step 1 and 2 of these examples, or for these problems. Now what we're just going to do is we're going to start out at step 3, and that was to find the lengths of the legs. So I'm going to count here. I go over 1, 2, 3, 4, 5, 6. I go over 6 times. Now I'm going to go vertically. I go over 1, 2, 3, 4, 5, 6, 7, 8. So I've got 6 across, 8 up and down. I'm now going to plug that into our equation. So we have a squared plus b squared equals c squared. I'm going to put 6 as my a, and I'm going to put 8 as my b. If you want to flip-flop those, that is totally fine. And that's going to equal c squared. Next, 6 squared, that's 6 times 6, so that's going to give us 36. 8 times 8 for 8 squared is 64. And once again, that's going to equal c squared. Now 36 plus 64 happens to give us 100. So we get 100 equals c squared. Next, we're going to square root both the c squared and the 100. Now the square root of 100 is 10, so we're going to get 10 equals c. Now because this is a whole number, there's no decimals, we don't have to worry about rounding, so our final answer is 10 is equals to c. And there we go. All right, now next, the last problem I said I'd help you out with is number 5. Now this is a problem where you're going to have to begin by doing those initial graphing of the ordered pairs, of those coordinates. So because we have several different points, please, please, please make sure that you're plugging it appropriately on the x, that you're plugging it appropriately on the y. So our direction state, find the distance between each set of points, when necessary, round to the nearest tenth. So here we go. Start off, I have -2, -3, so I'm going to go over -2 on my x, and I'm going to go down to -3 on my y. Next, I have 3, 4, so I'm going to go over to 3 on my x, up to 4 on my y. I'm going to connect my points together. Now I'm going to draw my triangle, and there we go. Now, vertically, I go down 1, 2, 3, 4, 5, 6, 7 times. And horizontally, we go 1, 2, 3, 4, 5. We go over 5 times. Our diagonal is our C. The diagonal will always be C in this case. So, let's set this up. We are going to go 5 squared plus 7 squared equals C squared. Now, if you want to put 7 squared plus 5 squared equals C squared, that's fine too. Next, 5 squared is 25. 7 squared is 7 times 7, so 49. Next, we're going to add these two numbers together, and that's going to give us 74. 74 equals C squared. Calculator's not working with me, so give me a moment. Now we're going to go ahead and square root both the C squared and the 74. And when we do that, we get 8.60 equals C. Now we don't really have to worry about the 0, so our answer is 8.6 is equals to C. Okay. Now, like I said earlier, number 8 on this assignment is going to be extra credit. I want to show you that real quickly. That is this problem here. You're still doing the same thing in how you're setting up the points on the graph. You're going to label your C. You're going to find the distance between everything. You're going to tell me what the hypotenuse is. But in this, it's a little tricky because of this 2.5 right there. So this problem is going to be extra credit. Okay. Now, if you have any questions at all, please leave me a comment, send me a message. I am here to help. Thank you so very much for watching. This has been Mrs. Ross Does Math.